So we were looking at radicals last time and doing some simplifying of radicals, and I wanted to just go back to this point. We only did half of this section, so this is probably Mod 3 Homework 2. All right, we'll guess that. Mod 3 Homework 2. We're simplifying radicals. Question 10 and 11 are different. A lot of times you can put the radicals back together. If you see something in the denominator and the numerator that would simplify, you can put them back together and get an answer better. If you try that in question 11, you're going to get stuck because you end up with a fraction that doesn't reduce. So sometimes it works for you and sometimes it would work against you. So I just wanted to go ahead and do these both. So for problem 10, this one is one where right now you have to put it together to be able to simplify because we don't know yet how to rationalize a denominator. But we do have something in common with the numbers and with the d's. So we can put it back together, make one radical, and we could reduce underneath. So the 2 and 8 will go 4 times. The d's you'll subtract, and this is just on the numerator. And then these are perfect squares. So square root of 4 is 2, and square root of d squared would be just d. So that one works very nicely to put them back together. If you try to do them separately, you would be stuck right now because the square root of 2 would be left on that denominator, and it's not a perfect square. I'm going to try to do 11 right here also. So there's our answer. For 11, it looks like the same kind of problem. It is the same kind of problem, but you can't use the same trick. Right? If you try to put these back together to make just one piece under one radical, the problem will be 24 over 25 does not reduce. You're going to be stuck with a fraction under a radical, which we don't want. So this one instead has a perfect power in this denominator. In the radical in the denominator is a perfect power. So instead, we should just clean it up there. So we're not going to do the same steps as the previous one. Let's work on the denominator first. It's easier. 25 is a perfect square. Square root is 5. And a squared, you divide by 2. 2 into 2 will go 1 time. So you have just a. Right, that's your denominator. For your numerator, 24, remember we simplified these with primes, the little factor tree. So 24, we could do 4 times 6. And we have 2 times 2 and 2 times 3. When it's a square root, every time you get 2 copies of something, that's a square. So 1 copy can go outside for that group. So we can take 1, 2 outside. These only have 1 of each. So they're going to stay inside and multiply back together. So 2 times the square root of 6 is going to be the 24. For the a to the 4th, that's a perfect power. 2 will go into 4 2 times. So we're going to take a squared outside with the 2. So this will simplify to 2a squared, and we have a square root of 6 here. Now, you do have something that will simplify a little bit. This piece on the outside could simplify with the denominator if there is a common factor. And you can simplify one of the a's off the numerator with the a in the denominator. And that will give us 2a times the square root of 6 over 5. But we had to approach it differently than we did the previous problem. All right. 12, I'm going to skip, but it's perfect powers in the denominator, so don't put them together. Just take your square root. All right, let's go to 13. And if you guys have a question, it's fine to stop me as we go. This session is for you. So you let me know if you have questions. So we have a cube root this time of negative 27 m to the 24th. All right, and you can think of your numbers and your variables separately. So we're doing cube root of 27, which is a perfect power of negative 27, and we're doing cube root of m to the 24th. Okay. So this one you can do on your calculator, and I did get a little calculator we can use. That wasn't what I meant to do. All right, so I want to do a cube root. So for most calculators, you're going to have to tell it which root you're doing. And so on the left, I have the x with the root. That is the one I'm going to have to do, and I'll have to tell it the 3 first. So I'm going to have to push in 3 for cube root. Second, to make it do this one above the caret. All right, and it's actually putting the 3 in that root. Underneath, I will put negative, this is your negative sign down here, negative 27, and enter. And I get negative 3. So it's okay to have a negative underneath a cube root, any odd root. And then the variable you will do by hand, you're going to divide by the index. 3 into 24 goes evenly, and it goes m to the 8th. So we're good there. 14 is our first one with a variable where it doesn't go evenly. So we're going to do a cube root of 27. 27 is going to be fine. That is a perfect cube. So that's not going to be new. You can do it on your calculator or remember. The answer to it is 3. So we have cube root of 27. That's a 3. But then we have to work on cube root of x to the 13th. So you're going to need to do some long division here. It's not horrible like sometimes. You're still going to divide by the index into your exponent. So you're going to do 3 into 13, right? And it goes 4 times. 4 times 3 is 12, and you have 1 left over, right? That's breaking it into groups of 3. You can have 4 groups of 3, so 4 cubes. That's how many will go outside. Right, now this is x to the 4th. Whatever your remainder is how many will go inside. So they did not make a group. So we are going to take x to the 4th outside. Make sure that you keep your index on here, otherwise you think it's a square root. And we have 1x left over on the inside. Good. Now, you could make your picture and see that this works. You would have 13 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you don't really want to do this. You are making groups of 3. There's 1 group, 2 groups, 3 groups, 4 groups. 1 for each of those goes outside. This is the leftover that goes inside. So that's what this long division is doing. All right, we'll try some more of these. So for 15, we're going to do cube root of 250e, which is just to the first. This is not like our, we're just going to consider it a variable, not our e like we would have in the calculator. All right. So I don't believe that 250 is a perfect cube. So I'm going to break it down with primes. Now, it looks horrible, but it's really not bad. When something ends in a 0, there's a 10 in there. So you have 10 times 25. And we have 2 times 5 and 5 times 5. All right, and then we were looking for groups of 3. And so we have a group of 3 right here. So 1, 5 goes outside. The 2 will stay inside. So we have a 5 going outside. Cube root. The 2 will stay inside. Now for our e, this is cube root of e to the first power. And you don't have enough of these. You only have 1 copy, so there's no reason to write them out or anything. You have to have at least 3 for something to go outside. So it's going to stay an e inside because you didn't have enough to make a group for it. All right, 16. And this one, you have 2 pieces that are perfect squares under there, so we're switching back to a square root. So you have to watch your index. So the 49 is fine. It's a perfect square. The square root is a 7, so that would go outside the radical. All right. The m to the 8th is fine. It is going to be a multiple of 2. 2 will go into 8 4 times. No remainders, so that's going to go outside. Now, what we have left to deal with is this r to the 5th. Right? So we will divide by 2. So 2 into 5 goes 2 times. These go outside. So r squared will go outside. The remainder stays on the inside. So we're going to take into the 4th, we're going to take 2 r's outside, and we're going to leave 1 r on the inside. And your order here of your variables does not matter. Because they're all multiplication, you can have any order that you want. We'll do this one just because it's a weird root. I was going to try to cut some of them out, but I don't want this to bother you with a 5th root. We haven't done any 5th roots. But you're just going to divide, just like the others. This one's going to make us work on every piece. Right, so when we work on the x's, we're doing 5 into 13. It goes 2 times. 2 times 5 is 10. And we have 3 left over. So 2x's or x squared is going outside. We're going to be left, I'm just going to scoot my radical over with x to the 3rd inside. Right, now I'll do my y's. 5 into 18. Let's see. 3 times 3 5s are 15. And I have 3 left over, so 3 are going outside. So that will be y cubed. And 3 are left inside. So that would be y cubed. Right. And then we'll do the z. We're doing 5 into 9. It's only going to go one time. And you have 4 left over. So 1 goes outside and 4 stays inside. So 1z outside and z to the 4th on the inside. Good. Um, 18 is actually one that's easier. It might worry you because it's a 4th root. It's actually 81 is a perfect 4th root. You could always test that. So we'll test that on a calculator. But for the variables also, the 4 is going to divide evenly. Right, so on our calculator, we'll clear. And if we want to do a 4th root, so you would do your 4 first, second, and your any root button, and 81, enter. And the answer is 3. So that one worked out even. Right, for your variables, 4 into 16 goes 4 times, no remainder. So g to the 4th, 4 into 36 goes 9 times, b to the 9th, and 4 into 28 goes 7. And so there's nothing left on the inside here, on this one. All right. 19 just has an extra number on the outside. And anything you take out there will multiply by that number. So we have 2 times the cube root of 27 x squared. So 27, hopefully you remember, is a perfect cube. If not, you could test it on your calculator or you could break it down with primes. You get 3 times 3 times 3. Right? So a 3 will go outside. It's going to multiply by your 2 that's outside. For your x squared, you don't have enough. 2 is lower than 3, so you're not going to be able to take any outside. So we'll put it back. And then these numbers on the outside should multiply. So 6 times the square root. Whoops, Mrs. H, that's an error. Cube root. If I didn't put that little index, you would think it was a square root. And if you did that on a test, if you were writing it down, it would be wrong. Okay, so be careful with that. All right, just a couple more, and these kind of go back to what we were doing earlier, whether to divide it ahead of time or not. And for right now, basically, if everything here will divide evenly into those, you can go ahead, because we would not know how to clean up a square root of 2. So, at this point. So, this one is better to go ahead and put it back together. Right, and so that's going to give us 8 over 2, and the x is still up here, which would give us 4. So we have square root of 4x, and the square root of 4 is 2. The x has to stay. It doesn't have anything to go with it. All right. The other one, and you might test on your calculator, because we could not simplify square root of 3. So we think we'll have to put it back together. You would test on your calculator, does 3 go into 147? And it's weird numbers, but it actually does. So this one will work out better if you do put it back together as one piece. And so we can do that on our calculator. I'm just doing the division. 147 divided by 3 gives me 49. So I am under my square root. I have 49, which we're happy about. Remember, subtract when you have a fraction with variables. So 11 minus 9 would be 2. And these are both perfect squares. Square root of 49 is 7, and square root of x squared is going to be just x. So both of these end ones, it's better to put them back together because they would reduce. All right, I think that is the end of that section. Let me switch into our next section. So this would be homework 4. So this is mod 3, homework 4. Is that what that said? Addition and subtraction. It also has some multiplication in it of radicals. And before we start, just quickly, to add or subtract radicals, they have to be the same index, number one. So like you can add square roots together or cube roots, but you can't add a square root to a cube root. All right, so they have to have the same index. Also, they have to have the same radicand. That is the piece underneath the radical. And then your math will be on those pieces out front. So the things that are like a coefficient if we just had a term. So let me sidetrack for a second and do a little tiny problem. So if I have 5x plus 3x, all right, you guys have been doing that forever. And you would say, oh, those are like terms. You do your math here. 5 plus 3 is 8, and you keep the variable. Radicals work exactly the same. If you have 5 times the square root of 2 plus 3 times the square root of 2, those are like radicals because the square root of 2 is the same. So your math is still going to be out here, and you keep one copy of the radical. So that is basically what we're going to do. All right, and they start you off with a couple of really nasty problems. We'll do one, just because there's so much work in these, to see if they are like radicals. So let's see if we want to do one or they're about the same. All right, we'll do one of them. All right, so we are going to do problem 1, and I probably better get a new sheet. Most of them are not this bad. All right, and the last piece is okay. Because you can't simplify the square root of 3. So basically on these 3, we have to simplify those first and see if we have any like radicals. So I'm going to work on the side. So I'm going to work on 180. It has a 10 times 18, and we have 2 times 5, and we have 2 times 9, and the 9 will keep going to 2 3s. All right, and so we have 2 squares under there. We have 2's and we have 3's. So we can take out a 2, a 3, and the 5 has to stay underneath. So this one is going to be 6 times the square root of 5. That is for the 180. The 6 that's going outside, so you had minus 5 out there. The 6 that's going out will multiply by that. And we're going to keep square root of 5 on the inside. So this is negative 30 times the square root of 5. Right, at least 12 is nicer. 12 is 4 times 3. And for 4, we can do 2 and 2. So, I could probably do that here. So 4 times 3, and there's our square. So a 2 goes outside, and the 3 is left. So this one is plus 2 times the square root of 3. Right, next one we're going to have to work some. I'm going to need to erase this. So if anybody just looks at the notes, you'll have to match it up to the video to get all of it. I print from these sheets at the end if you ever need that. All right, 245. Now, to help you start breaking this one down, it ends in a 5, so you know there's a 5 in there. All right, and I'm going to get a calculator to help me. So, 245 divided by 5 gives me 49. So, it seemed horrible, but it really wasn't so bad. There's your square right there. So, we're going to have a 7 going to the outside. So, 7 goes outside. Now, watch out. We did have something on the outside there. We had a minus 4. We are taking out a 7, and we're leaving a 5. So this is going to be minus 28 square root of 5. This one was already simplified, plus 5 square root of 3. And I'm going to get this out of the way. All right, now you're going to pick your radicals. You have 2 kinds of radicals here. It's just like having an x and a y. Right, so first we'll do these square roots of 5 together. Your math is on the outside, so you have negative 30 and negative 28. Like signs add and keep the sign to negative 58, and you keep 1 copy of the radical. And you could feel free to use your calculator if you need to. Right, the square roots of 3 will go together, and your math is outside. So 2 plus 5 is 7. And 1 copy of square root of 3. All right. Oh, no. Mrs. H has an error, huh? Right, on this one, all right? When I took the 2 out from the 4, I had a 2 out there already. And I'm taking out the 2 from the 4, because it was 4 times 3. So this should have been 4 times the square root of 3. All right, and those are still going to be the ones to go together. And that is how we should have got a 9. Sorry about that. All right, I'm going to skip that other one just because it's very long and it's the same kind of work. This one looks really different. It's 3 questions. They've just put it all in one thing. And on the first part, you have to make sure they are like radicals. You don't have to break any down on this one. Right, so the square roots of 5 are alike. They can go together these two. This one cannot. It's a cube root of 5. So it's going to, these are going to be like x's and that's a y. It's going to stay by itself. So this would, remember, if you don't see a number in front, it's a 1. So this is negative 5 plus negative 1. So we get a negative 6 times the square root of 5. And this is just going to stay 7 times the cube root of 5. Good. We might type that one in to see if there's anything that should give you trouble. So negative from your keyboard. 6 and your square root of 5. Make sure you get out from under the radical. So you can click at the end, or you could have used the arrow button. Either one. And then I need plus, right, and I need this other root button. Oh, I didn't do the 7 yet. 7. The other root button, all right, now the cursor is for the index right now. 3 and 5 is in here. That's your radical. Right? So that way you can just see how to put things in. Right. Let's go to the next one, and we'll submit at the end and see if I did that right. What you have to watch for here, you have those parentheses, but you have a sign in between, so they're not multiplication. This is going to be just combine, and you're going to need to distribute that minus to the second one. So the first parentheses does not really matter. There honestly is no reason to have it on there. But before you remove it, always make sure there's no exponent. There's not. And make sure there's nothing out in the front to distribute. There's not. So there's no reason for this parentheses. For the next one, this minus distributes to both. So we have minus 6 and plus 5 square root of 6. And now we can put together. So these two are like radicals. So 5 minus 3 is 2 times the square root of 6. And these constants, negative 6 plus 1 will be a negative 5. All right, and they've just switched the order, which is fine as long as you keep your right signs with the right pieces. All right, let's see. And the last one is just going to be combining. So negative 9 times the square root of 15. 15 will not break down. If you try, it gives you a 3 and a 5, which are both primes. So there is nothing else you can do to it. All right, so there's nothing we can do on this first one. The second two are like radicals, and that is a negative 2 and a negative 1. So that is a negative 3 times the square root of 5. And this one just stays. Negative 9 times the square root of 15. All right, I'm going to check this to make sure I entered the correct first one right. It will mark me wrong for those other two. Good. All right. 4 and 5 are much more standard questions than the others we had here. So 4, we'll do it just because as a variable in there. So negative 9 times the square root of 8x plus 6 square root of 50x. And you have to break these down to see if they will simplify. So for 8, we can do 4 times 2, and 4 is a perfect square. So we do have a square in there. The 2 will go outside. It will multiply by the negative 9. So we have negative 18 square root of 2, and don't forget about your x. All right, this one, 50, we could do 5 times 10. 10 is 2 times 5. And we'll make one group there. 1 5 will go out for that group. So we've got 6 times 5. The 2 is left. So this is plus 30 square root of 2 and an x. And these can go together because both have square root of 2x. So your math is on the outside. 30 minus 18 would be 12. And you keep your radical just like it is. So that was 4. Right. We'll do 5. This one is a nice standard question because the numbers are not so crazy there. So you have 18 times the square root of 2 minus 10 times the square root of 72. Right now you can't do anything. They're not like radicals. So you have to see if either one will simplify. This one will not because 2 is prime. So 72 you can do 9 times 8. And 9 has 3 and 3, so it has a square. It is a square. 8 has 2 and 4, and the 4 will keep breaking. All right, so for a square, we have 2 squares in that one. We have a 9, so we get a 3 going out. We don't forget we already had a 10 out there, and we have a 2 going out, and we have 1 2 left. So we have 18 times the square root of 2 minus 10 times 6 will be 60 times the square root of 2. And these are like radicals. They can go together. Your math is going to be out here. So 18 minus 60. And you can do it in your head or you could pull up a calculator. It is a negative 42. And keep the radical. Right, so if you see if radicals will simplify so that you could get the same radicand, and if so, then you can combine the numbers outside. All right, we'll do 6 and we're going to skip 7. So 6. Negative 3 times, these are square roots. All right, 80. So I would start with 8 times 10. And there you have a 2 and a 4 and a 2 and a 5. And the 4 will keep breaking. Right? And if you don't bring everything down all the way, just be careful. All right, so there is a group of 2, and here's another group. So you're taking out 2 2's. You have minus 3 times 2 times 2, which will give us minus 12 times the square root of 5. And I didn't leave enough space there. I need to do my variable. So I'm going to divide 2 into 3. Goes 1 time with 1 left over. So you're going to have an x out there. We'll squish it in, and you're going to have an x left over in here. All right, for this one, 20. So we can do 4 times 5. And we can take a 2 out. So negative 4 times 2 will be a negative 8. You are going to take out an x. We are left with a 5. And also we're left with an x. This took care of 2 of them. We have 1 more left over. And these are like radicals. You're going to do your math out here. So you're adding these. You are doing negative 12x minus 8x. And that is going to be times square root of 5x. So your math is going to be just on these coefficients. So this is going to be a negative 20. Keep the x times square root of 5x. So it doesn't change to x squared out there. Okay, just x. Good. All right, so we're going to skip 7. Number 8 is a little tricky. So we'll do it. This is one where you don't want to put the radical, it's already in 1. You are going to actually have to break it into 2. There is nothing you can do under here, so we'll break it into 2 pieces. So we have cube root of 7 and cube root of 125. You might remember 125 is a perfect cube. Otherwise, you could try to break it down or check it in your calculator. It is a 5. So we have cube root of 7 over 5. This one there is nothing to do right now. Now, they're going to take you for a little spin here and throwing you back into the world of fractions. So you're doing this hard stuff with these radicals that's new, and now they want to talk about fractions. To add or subtract fractions, you have to have a common denominator. And for these two, because they're both prime, you're going to need them both. And so we're going to need a 35. Sorry, a 35. I just need one of each. All right. So this one, to get the common denominator underneath, it's going to need a factor of 7. Remember, you do that numerator and denominator. That's what makes it okay to do, because you're really multiplying by a special form of 1. This one, I'm going to do a 5 and a 5. All right, so we have 7 times the cube root of 7 over 35 minus 5 times the cube root of 7 over 35. And now these can go together. So your rule is keep the denominator and combine the numerator. Let's see if I can get that to give me a little bit more space. And it's not going to today. All right, so we will keep the denominator and we'll combine the numerator. These are like radicals, so your math is going to be on the outside. 7 minus 5 is 2. And 1 copy of the cube root of 7. All right, let's enter that one because it might be tricky. We need a fraction button first. We need 2 and a cube root, so any root button. We need to put, the cursor is where the index goes, so we'll put that. And then we'll click inside here. That is a 7. Go down, that should be a 35. Hopefully Miss H didn't make any error there. So that one I think is a tricky question, kind of out of place maybe. All right, next we're going to switch it up and look at some multiplication. And basically with multiplication of radicals, you can multiply whether they're like radicals or not. You do need the same index, but you don't have to have the same number underneath. When you do the same radical times itself, as long as they're positive underneath. You can just multiply them together. All right, so also basically things that are outside multiplied, things that are inside multiplied. So this one, we are looking at a FOIL problem here. Hopefully you would recognize that. It is two binomials multiplied. And so that's what would tell us, okay, you're going to do a FOIL here. And so we'll do the first ones. I'm going to write the steps here. It'll be easier when you're used to it to not write the steps. This is what we're multiplying though. And the 2's will multiply to give us 4. When you multiply the same thing times itself, it will remove the radical. So this will just give us an x. Would be square root of x squared if you multiply them and then you clean that up. All right, that's the first terms. We're going outside. So we will have, we're doing 2 times the square root of x times negative 6 square root of y. So we have negative 12. That's outside. And the insides are just going to multiply together. So they're going to sit together. All right, now we'll go inside. So we're doing 6 times the square root of y times 2 square root of x. So this would be plus 12. And yx and xy are the same. So we'll write them same order. And then we're going to do the last terms, which are these two. It is going to be minus, and the 6 times 6 will give us 36. You have the same square root times itself. It's going to remove the radical. Then you're going to look at putting these together. A lot of times you get like terms from the outside and the inside. You did get like terms here, and they're going to just cancel each other out. So we have 4x minus 36y. You guys doing okay? All right, we'll go ahead and do number 10. So it's the same kind of problem. Two binomials, so it will be a FOIL. And that gets you started just to realize that. So you're going to do your first terms. Now, same radical times itself will remove the radical, or same square root times itself will remove the radical. So this gives us 10. Outside, these are going to multiply underneath. So it's going to be a square root of 30. Inside, it will be a minus 13 times the square root of 30. And then last, right, the square root of 3 times square root of 3 will give you just a 3. So we have 13 times 3 is a minus 39. All right, now we're going to put radicals together. And so our constants, these are going to give us negative 29. For your radicals, remember this is a 1 in front. So 1 minus 13 will be a minus 12 times the square root of 30. And we need to make sure that we can't break 30 down. 30 we have, because it's a little bigger, we have 10 times 3, and 10 gives us 2 and 5. We have all primes there, and we don't have any groups that match. So it is going to stay like that. Good. So next we have 11. So square root of 5 plus 7 times square root of 5 minus 7. Multiplying binomials. You might remember the term conjugates. These are conjugates, like pieces with the opposite signs in the middle, and something special happens on them. Let's go ahead and just do it as a FOIL, and we'll see what happens. So square root of 5 times itself, we'll take the radical off and give you just a 5 outside. Now, this minus 7 will multiply by the 1 that's out front. So it's just minus 7 times the square root of 5. And your inside will be plus 7 times the square root of 5. And last, minus 49. Right, your constants can go together. So this will give us a minus 44. And notice these other two are going to cancel each other. If minus 7 square root of 5 plus 7 square root of 5, they're going to cancel out to leave us just a negative 44. All right, question 12. Basically here, remember to write it twice and do FOIL. All right, so I would write it 2 times and do the FOIL. You are squaring a binomial. So first times, it's just going to remove the radical. Give you a plain old 3. Outside, you get a minus. You're going to multiply underneath, square root of 21. This one, you're going to multiply underneath, minus square root of 21. And last, 2 negatives will give you plus, and the radicals, same thing times itself, will take the radical off and leave you a plain 7. So your 7 and 3 can go together to give you 10. Remember your coefficients on these. This is a negative 1 and a negative 1. Will give you a negative 2. I'm sorry, I was thinking something else. So 7 and 3 went together. Negative 2 here, and keep your radical. Sorry about that. Right? Now, be careful and don't try to put this 10 minus 2 together. You're not allowed, because this is like it has an x with it, because it has that radical. So this is as far as you can go on this one. Right. I am going to skip the next one. Just remember things outside multiply and things underneath multiply. Right. We'll go to 14. 14 is a distribution problem. It is like a monomial outside. It's just one piece. And so we're going to distribute, and this negative 4 is going times the 1 in front. So plain numbers, we're going to multiply by whatever's outside. So this will be negative 4 times the square root of 5. And this one is like a 1 out here. So 1 times 3 will be 3. And square root of 5 times square root of 5 is plain old 5. You remove the radical. So we'll have to work that out, and that gives us a 15. Good. All right, and we can skip 15. It's very much the same. 16 is going to be a FOIL. Very much like what we just did, so we'll skip it. 17, you just have to, you can multiply these just like they are. This is a nasty problem. I'm not going to do it. That's a 10-minute problem. But you could go ahead and multiply those, and then you have to break them down and simplify at the end. 18. So I did pick 19 out of these. So let's go to it. All right, and I would just distribute first, and then try to clean this up. So we have 2 multiplications. So we're doing this first one. So first we have 4 times 7 is 28, and we have our radical. This y is going underneath with the other y's. So now we have xy to the 4th. So the square root of y multiplied by these. And the pieces underneath can multiply. Right. This we can simplify the y's. So 2, which is your index, 2 and a 4 will go 2 times. So this will give us 28y squared times the square root of x. All right, let's see how the next one turns out. So it's 4 times 1, so it's just going to be plus 4. Square root of y times square root of y cubed. So the y would just go underneath with the y cubed. That gives you 4 of them. And 2 into 4, 2 for the index, into 4 will give you 2. So this is going to come out from under the radical and just give you a y squared. These cannot go together because the first one has a radical. The second one does not have a radical. So they are not considered like terms or like radicals. Good. Right. We can go back to that nasty one. I'm not going to go to the next section. I'm running a little bit behind schedule, and that's okay. You can do your notes for that next section also, but don't feel like you have to have all the homework caught up. That next section we're going to have, which was on today on the schedule, that Mod 3 Homework 2, rational exponents, that is fractions for exponents. That section takes a little bit of time. Right, so we will do it next time. Let's go back. We'll do this nasty problem. We'll see if Mrs. H can do it today. All right, it's a FOIL. You know what might be easier is if we try to break these down to begin with. Instead of multiplying like 75 times 48 and get something really huge, maybe we break them down to begin with. All right, so let's try that. So 75, we have 3 times 25, and 25 is our square, which gives us 5 times 5. So this gives us a 5 on the outside times the square root of 3. This is going to be easier, right? The 112, let's do that one. Now, that's a harder number because it's not something we think of, but it ends in an even digit. So we know there is a 2 in there. And just get your handy-dandy calculator. And 112 divided by 2. So that's 56. 56 will break on down. 7 times 8, and 2 is prime, 7 is prime, 8 is going to give us some more. So 4 and 2, and the 4 gives us some more 2's. All right, so out of this, here's one group of 2's, and here is another group of 2's. So 2 times 2 is 4 on the outside, and your 7 is left. Right, let's see, 48. I see 8 times 6, and 8 is 2 and 4, and 6 is 2 and 3, and that 4 is going to keep going. So just be careful if you don't bring them all down. All right, so groups of 2, there's one group and another group. So a 2 and a 2 outside gives us a 4 outside. Square root of 3. And 32. I see 4 times 8. This one gives us a bunch of 2's. All right, so there's one group and one more group, and you have one left over. So 2 times 2 on the outside is 4 times the square root of 2. All right, yes, that was definitely a much better. Simplify first on that nasty thing, and then we'll do a FOIL. All right, so outsides are going to multiply. So we're doing this one times this one. So 20, square root of 3 times square root of 3 is going to remove the radical. So we're going to end up with 20 times 3, which is 60 on the first terms. Right, now we'll go outside. So 5 times 4 is 20, and these underneath will multiply. So we have 20 times the square root of 6. This inside will give us 16 square root of 21. And our last piece, we're multiplying last. So 4 times 4 is 16, and this will give us a 14 underneath. All right, and this is 2 times 3, this is 3 times 7, and this is 2 times 7. All those are primes, so nothing is going to break down. This is actually going to be the answer. So let's look and see if it is. So 60 plus 20 times square root of 6, 16 times square root of 21, and 16 times the square root of 14. So it wasn't very pretty. All right, I think we get to stop on that one. That's enough for today. I hope you guys have a good weekend and keep working on this. Send me questions if you have them. If anyone has not done their PDF upload file yet, you need to do that. It is just putting a little app on your phone. I like Genius Scan because it's fast and easy and it's free. But it works really nicely. So, and that's from your left toolbar, PDF Upload 1. So if you haven't done that, make sure that you do. All right, you guys have a great day.